Hello, Pre-Calc. Today we're going to take a look at Chapter 4, Section 6. You'll be sketching the graphs of secant and cosecant functions, and then looking at something that's kind of neat called a damped graph. You'll analyze those. So, grabbing your summary of parent functions, let's take a look at secant. Think about secant in terms of what is it the reciprocal of? Well, secant is the reciprocal of cosine of x. So seeing how it's 1 over cosine of x, that means there are certain values that can't go on the denominator. You can't divide by 0. So we have to start thinking about when is cosine equal to 0. Think of your unit circle if you need to. Cosine is 0 at what? Well, when x is pi over 2. 90 degrees. That's one of them. So let me graph my cosine function. We start at 1, we go to 0, we go to -1, we go to 0, we go back to 2 pi. So I can see I'm 0 at pi over 2 and 3 pi over 2 and so on. Going to the left, I would be back down to 0, -1, 0, and +1. So here's my graph of cosine. And everywhere that we have a 0 value, well, that means we're going to be dividing by 0. So at pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, this is a gap of 90 and 90, 180 degrees, value of pi. This is a gap of 90 and 90, 180 degrees, a value of pi. So it's every value of pi past here, past here, past here. It's your pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. It's your pi over 2 plus any value of pi. And what happens at each of those points is cosine is 0, which means 1 divided by 0 is undefined. Therefore, secant is undefined at this. Every pi over 2 plus n pi, secant is going to be undefined, which means we have a vertical asymptote everywhere that happens. Everywhere that cosine is 0, secant is undefined. All right, so now what? Well, let's look at some other angles here. Like x is 0, cosine is 1. So 1 divided by 1 would give me a value of 1. At pi, cosine is -1. 1 divided by -1 is -1. So it looks to me like at 2 pi, we're going to be here again. At negative pi, we'll be here. And at -2 pi, we'll be here. So it shares those points. But everything else is the reciprocal. So let's think about what's between 0 and 90. 0 and pi over 2 would be pi over 4, or 45 degrees. What's the value of cosine at 45 degrees? Radical 2 over 2. So cosine of 45 degrees is radical 2 over 2, which is about 0.707 if we're graphing. To get our secant, we would take the reciprocal of that. It'd be 2 over radical 2. We'd have to rationalize. Times radical 2 over radical 2 would give us 2 radical 2 over 2, which is just radical 2. What is that value? Well, put that in your calculator if you don't know it. The square root of 2 is about 1.41. So at pi over 4, we're up at 1.4. At negative pi over 4, we're going to be here again. What we get is kind of like a parabola. Same thing happens here. Same thing happens here. Same thing happens here. Oh, too high. The blue represents the graph of secant. The red is your graph of sine. Not sine, cosine. Notice that the hills and the valleys of cosine and secant, they kind of match, right? Those points match. But then everything else is the reciprocal. Also notice that your s-intercepts of cosine are your vertical asymptotes of secant. So, you and your partners, how about you take a few minutes to practice graphing cosecant and secant. Maybe 15, 20 minutes tops. And then when you're done with that, you'll have a little Desmos on damped trig functions. And finally, you'll end up with graphing tangent. But before that, let's take a quick look at a neat little brain break. You'll like this one. This is good. Somebody sent this to me a few years back, and I thought it was pretty funny to share.
So nobody on your planet uses math? Nope, never heard of it. Okay. Say, what is math anyway? Well, okay, so let me get this straight. You guys spend all day just writing these weird, freaky symbols? Are you in a cult? No, it's for science. Math is the language of the universe. Well, apparently the universe had a stroke because this is nonsense. How did your kind achieve space travel without performing the necessary calculations? It's a rocket. You blow some stuff up and it shoots you into space. It's not that hard. Oh my God, you even write it on the wall. Like a psycho. Well, that's a whiteboard. We use it so we can teach children. You do this in front of kids?
Yes, we do math. That's right. All right, so group work. When you're done with that, Desmos, you're going to look at damped trig functions and a quick little demo of what harmonic motion deals with is we're breaking out our old slinky again. There you go. Over time, what's going to happen to the motion? If I don't keep up the movement over time, the motion becomes less and less and less until it totally stops and reaches equilibrium. Right? Ended up with graphing tangent. Have fun with your online homework. See you guys next time. Bye.